Okay, so this is the effect we are going to work on. It's fake water made using particles, using the VFX graph inside of Unity. So because it's made using the VFX graph, it's fully interactive and fully customizable. For example, here I have the particles parameters and I can play with the size. Also the spawning, I can make some kind of a spray, like so. Maybe, let me turn it around. Yeah, like this. Or you can also make something that is not water, something that behaves more like lava, just by changing some physics attributes. So this is what we'll do during this tutorial. As I said, we won't do so much shading, but mostly programming, because we will do it with custom passes. If you don't know what it is, don't worry, we'll see in a minute. But first of all, I just want to let you know that everything is available on GitHub, the whole Unity project. So in case you want to try it yourself and experiment, you can. Feel free to do it. Alright, so for the shading, there is already everything available in ArchGAP. So yeah, this tutorial is running on ArchGAP, not on URP. And in ArchGAP, you have already support for refraction. So here I have a sphere with a classic lit shader, and that shader is in transparent, and you can already enable refraction right here on the refraction model. So with that, you can already start to get a glass or water look. And actually what you see here is just a bunch of spheres, like this one, but we blur the normals. So let me configure that. Don't worry about the interface, we'll do that later. If I remove the blurring, this is what we have. So it's just the same as this, but duplicated many times. And what we'll do in this tutorial is write a custom path that will blur the normals, like so. So we will go through each step, like how to write your first custom path and stuff. And yeah, you should be able to learn about custom passes. So let's take a look at what's happening under the hood rendering-wise. So I will start the frame debugger. I need to play the game to do so. Okay, so you have frame debugger inside of window analysis, frame debugger. And here you can see everything that is happening on each frame. So on the left, you have all the instructions that are executed each frame. And you can see there's a lot of things, and they are folded. But what we will focus on right now is the rendering of the water. So there's two custom passes required to do the water effect. The first custom pass will render the particles into a buffer. So right now you are viewing the buffer, and this is what we see here. Here is particles normals in wall space. Then we use a Gaussian blur on this buffer. This gives us this look, and then we just use that buffer to render the water. So this is pretty straightforward, but if you never have written any custom paths before, I think you will be able to learn some new stuff right here. And by the way, the pool that you see at the bottom is just another VFX graph, but the particles are spawned randomly inside of a box, and they don't have gravity, just turbulence. Okay, so let's dive in. In the project files, you will see there is breakdown folders with few steps, and we just go through each of them. Okay, so first thing, the particles. Where are you? Here. So the particles, we will go through the VFX graph to see how is it made. First, maybe I should talk about the Unity version and stuff. So I'm using Unity 2020, the long-term support version, but it should work on any on newer versions as well. And for the packages, I'm using shader graph, visual effect graph for the particles, and RGP, and this is the latest available versions. Okay, so for the particles, here I have the VFX graph that I can move around, and it's colliding with a sphere at the center here, and a plane for the floor. I have the same setting as before. I can play with the velocity and stuff. And let's take a look at the graph. So let's wait for Unity to open it. There we go. All right. So spawning, we don't have anything special, just a constant spawning. Then for the initialization, we have some random velocity, a specific lifetime and size, and a random position inside of a box. Then for the update, we have two colliders, the sphere and the plane, that are placed in world space, so that when I move the emitter, the colliders stay in place. Because if I put them in local, they will follow the emitter, and that's not what I want. Then we have some turbulence and some gravity, and drag. So drag is something that will slow down your particles over time, like this one. And by playing with these values, drag value, you can get something that is much more sticky, like lava, or something that that slides very easily on the floor, like water. Then in the output, we play with the scale. So we want the sphere to be stretched using its velocity. So the faster the sphere goes, the more we want to stretch it. So we take the velocity, and because it's a vector, sorry, not a direction, it's a vector, we take the length of that vector, and then we use that to sample a curve so that we can configure the scale based on the speed. So here, for a speed of 4, I choose a scale of 5, and I can play with that. So I find it very convenient to use curves in the VFX graph to configure the behavior. And yeah, you don't have to put time values. Here I just put a speed value. And then I turn the spheres along their velocity. For the output, if I click on the output block, I'll have an inspector with more settings. There's nothing special here, just make sure it's in opaque mode. And for the shader, let's take a look at the shader. So the shader is pretty straightforward. We just take the normal in world space and plug it into the color. I can just plug something else to show you that you can put whatever you want here. And we will use that world space normal later for the water rendering. For the shader settings on the graph inspector, just make sure it's unlit, because we want the real normal values. If you put it in lit, the lighting will affect the values and you won't get the good values anymore. And for the target, I'm using visual effects, but I think if you are running Unity 2021, there is no visual effect target anymore. You'll have to choose RGP, and inside of that, you will have a checkbox for the support of visual effect. Alright, so that's it for the particles. As you can see, it's pretty simple, and the good thing about this setup is it's fully customizable and you can add features on top of it pretty easily. Okay, so let's open the next breakdown step. So now we will talk about custom passes. I will just disable that for a moment. Maybe create a floor. No, it's too bright. Whatever. So custom passes, what it is. Custom passes is a way to add your own rendering features inside of the rendering loop of Unity. So if you want to do like blurring, bloom, depth of field, outline, ghost effects, any kind of rendering features that you need to execute it every frame, you will use a custom pass. Basically, you can think as custom pass pretty much as post-process volumes. I think that's what they were called before. And I think we still have post-process volume. So to create a custom pass, right now you have a thing in the volume menu called custom pass, and that will create a custom path volume. By default, it doesn't do anything. We won't care about the mode, injection point, and priority right now. We talk about it right after. And then you have a list of custom passes. So basically, in this list, you can add multiple things to modify the rendering. By default, you have 3 things available. The first 3 right there: draw renderers, full screen, custom clear. And everything below that is something I wrote for the tutorial, and we will take a look at it after. So let's just choose custom clear, and I will just put a clearing flag. So this pass is just clearing the camera buffer. So you have the ability to enable or disable the custom passes, give it a name. And the name is pretty important because this name will show up in the frame debugger that we used just before. So in case you have a problem, this will be really useful. And for the targets, right now we are working on the camera buffer, but we could choose something else. Don't worry much about it right now. We'll use it later, but right now we just target it to the camera buffer. And for the clear flags, well, what do we want to do with the camera buffer? Do we want to clear it or not? If we don't clear it, then this custom pass doesn't do anything. And if we choose a clear flag, we just clear it. So it's pretty useless, but it's just to show you how it works. The first setting you have is a mode. So it basically tells where your effect should work in world space. If you choose global, it will work everywhere. But if you choose local, it will work only if the camera is inside of the collider. So here I put a collider, and the effect will only be enabled if I'm inside the box, like so. So it can be great for optimization or stuff like that. But here we don't need that for the water. We just choose global. Then you have the injection point. So when Unity does a rendering, many things happen, and you can choose where do you want your rendering features to be executed. So for the water, we will choose before transparent. But for instance, here, if I choose to run this before rendering, then it's useless because I choose to clear before rendering, and I will render on top of it. So my custom pass isn't doing anything. So for this tutorial, we will just choose before transparent. Then you have the priority. So this is useful when you have many custom pass volumes and they overlap with each other, and it will define the order of the execution. So speaking of order of execution, let's have a look at what does it mean. So I will create another pass called draw renderers. I will just configure it, but don't worry, I'll explain later what it is. And this custom pass will draw the particles. Okay, so basically you can sort your custom passes in this list, and this will define the order of execution. In this way, the clearing is executed before the draw particles, but the other way, the draw particles is executed before the clearing. So the particles are cleared, and then it's useless. Let me open back the other custom pass. So here I have a custom path that draws the particles. For the water effect, what we want to do is blur the normals. As you can see here, we have the normals, and we want to blur that. Because we want to blur it, we don't want Unity to render the particles. We want to render them ourselves so that we can blur it. So what we do first is disabling the particles from rendering. Here the particles are here, but you can't see them. That's because they are inside of a layer that is not default. I put them in another layer. Actually, you can choose any layer. You can even create your own layers. And I choose this layer, for instance. And that layer is also disabled for the viewport preview. And it's also disabled on the camera, right here in the culling mask. If I enable it, we don't see anything in the game. That's because the camera is not at the correct position. Where is it? Where is it? Yeah, it's here. Here's a quick tip. If you want to put the camera at the same position as the viewport, this viewport, you select the camera in the hierarchy on the left and you press Ctrl-Shift-F. And right now the camera, both cameras have the same position. Alright, so now if I disable the transparent FX layer from the culling mask, they won't render anymore. And I do the same here in the viewport. And now the particles are enabled, but they don't render. So what we do with this custom path is render the particles. To do so, I'm using a custom path called draw renderers. The first parameters are the same as before. Actually, as maybe you have noticed, but every time the first four parameters are the same. So you always have a name, a target, and a clear flag. But sometimes we don't have to. Sometimes we don't really mind about it, and we handle the parameters ourselves inside of the script. We will see that afterward. So yeah, this custom path will render the particles on top of the camera. You can choose to clear everything or not. If you don't clear, it will put the camera on top of the scene. But if you clear, it will clear the camera buffer before. And here you choose in the filters, what do you want to render? And I choose to render this layer. If I choose another layer, it doesn't show up anymore. All right. Yeah, so you always have a color buffer and a depth buffer because they are not the same values. In the color buffer, you have the RGB values of the surface, and in the depth buffer, you have the distance to the camera for each pixel of the object. And we'll use that later. So if I take a look at the frame debugger right now, you will see how this is executed by Unity. Yeah. So we can see our custom path here, draw particles, and inside of this, you will see a clear instruction and a render loop that will render the particles. And if I decide to change the target to custom, first of all, they won't show up on the camera anymore, but the rendering is still happening. If we look at frame debug, if you look at the frame debugger, we still have the clear, the render loop, but the rendering is not happening in the same buffer anymore. Right here, the render target is a custom path buffer. So it's still happening. It's just that it's inside of a hidden buffer, and we don't see it anymore. Actually, we will use that right after, because we want to do some blurring, and we don't want to blur the camera buffer. We just want to blur the particles. So we will put them into the custom buffer. Okay, so let's jump into the next step. And actually here I made a lot of custom passes to show you more concrete examples. And all these examples are made in C#, and we will take a look at the scripts. So the first one is just clearing the buffer with a color, and you can choose the color right here. And here, just after the name of the custom path, between the parentheses, you have the name of the script. So the script is simples custom path. Let's take a look. Okay, so this is a custom path that is written in C#, and this is where you can write your own code to add your own rendering features. If it feels overwhelming, don't worry, we'll go through each of these steps. So the first thing you have to do is create a class that inherits from custom path. As soon as you do that, it will show up in this list, and you can add it, like so. Then we have the parameters we just saw, so the clear color and clear flag. Here I added a clear flag on top of this one, but it's just to show you how to create this kind of parameter. It's not very important. Then you always have three methods setup, execute, and cleanup. We don't care about cleanup and setup for now. We will talk about it in the next examples. Now let's focus on execute. So execute will be executed each frame for each camera. What do I mean by each camera is that if you have multiple cameras, like here, I have two cameras, the viewport on the right and the game on the left, it will be executed 2 times. And this is pretty handy if you want to make something that works in the editor and you need to work on it without having to run the game each time. Then we just call the base execute method. By the way, if you don't really understand this syntax, override base.execute, don't worry, just copy paste it and one day you will learn about classes in C#, but you don't have to worry so much about it. Okay, and the only instruction that we care about is this one, and this is the one that will clear the camera buffer with a custom color. So first I should explain what is this, the context. So we are always given a context, and inside that context, it's an object where we have access to the camera used for rendering. We have access to the camera buffer, the camera depth buffer, normal buffer, and all kind of stuff. And we also have access to command buffer. So command buffer is something that existed, that was here way before RGAP in Legacy. It's basically a list of instruction, rendering instruction, like draw mesh, clear, stuff like that, that Unity will execute. So when you create rendering features, when you write rendering features, you will basically add stuff into a command buffer and Unity will execute it. Where is the script? Here. So to clear the buffer with a color, we call this method. We first give the command buffer, because behind it will add the rendering instruction to clear the buffer. We give the buffer we want to clear, so the camera buffer. And how do we want to clear it? So here I choose to clear everything, but if I choose none, nothing will happen. So I choose to clear everything with a specific color that I can choose here. Under the hood, this is basically adding commands. Under the hood, it basically adds instruction to the command buffer. So behind this, actually you can look into it because it's open source on GitHub. Every code related to RGAP, URP is on GitHub, and you can look into the code. So what's happening inside of this is Unity is just doing things like so, like context.commandbuffer.setRenderTarget and then clear. If you never heard of render target, basically when you want to draw something, you always have to first tell where do you want to draw it. So if I want to draw a mesh, like here, line 30, I first have to tell, okay, I want to draw my mesh on the camera color buffer. If you don't do that, then we don't really know where your mesh will end up, and you will get funny things. So always make sure to set your render target before you do something. And yeah, that's it for this one. Okay, so the next one is a bit more advanced. It's a blurring of everything you see on the screen. And actually this can be used for any effect like window effect, fog effect, stuff like that. So what do we have is a blur radius, a sample count that will define the quality and also decrease the performance if you choose too much samples, and a checkbox to downsample the buffer, meaning make it half the size, because when you blur something, you don't have to keep it full resolution. Okay, so let's take a look at the C#. It's this one. So first we have the 3 parameters we just saw and played with. Then we have some things we don't really saw yet, so don't worry about it, we'll talk about it after. And let's focus on execute for now. So in Unity, you don't have to write blur by yourself. There's actually a Gaussian blur already implemented, and we just call it. So first we have to give the context. Then we have to give which buffer we want to blur. So here we want to blur the camera buffer. And then we need to give a temporary buffer, because when you blur something, you always have to make a copy of what you want to blur. You can't just blur the buffer itself. So Unity asks for a temporary buffer. And I'll explain after how to create that. And then the blur parameters, which are the sample count, the radius, and a downsample checkbox. For the radius, right now the radius that we edit here is like I don't know, maybe a number of pixels, but actually you don't want to have a number of pixels because otherwise if you are in 4K resolution, 2K resolution, the result won't be the same. So it's best to multiply by the scale of the camera buffer so that the result is always the same, no matter the resolution of your screen. All right. So for the buffer, we use what's called the RT handle. RT is short for render texture. If you never heard of render texture, it's just an object, a texture, which can be 2D or 3D. And you can draw stuff into it, you can read from it, from the GPU or the CPU. And the RT handle is just a render texture that you don't have to worry about the size at all. Let's say you are in 2K or 4K resolution, Unity will just resize it according to the user screen's resolution. So to create it, we do it in setup. So setup is a method that is called only when we enable the effect the first time, and it's only called once. So this is where we will create the buffers. Every expensive stuff, we'll put it there if possible. So to create the buffer, we just do rthandles.alloc. Then we give a scale factor. So if we give 1, it will be 100% of the screen resolution. But you can actually do something like 0.5, and it will be half of the screen resolution. Then we have the dimension. Because your text in Unity, you can also do VR, virtual reality. In such case, you don't have one buffer for the camera, but you actually have 2 buffers, one for each eye. And you actually need to create 2 buffers instead of 1. And these parameters will just choose the good values depending on if your game is in VR or not. And then the name of the buffer. So this will show up in the frame debugger. Always make sure to choose one. It will save you a lot of time if you encounter some problems later on. And because we create a buffer, we always need to release it. So we do this in cleanup. This is executed when we don't need the effect anymore, and you have to destroy the texture, otherwise you'll have some memory leaks. All right. So next one is, I think the next one is simpler. It's just drawing a mesh in the scene that you can move around. As you can see, it doesn't interact with the scene. We'll see that just after, where the mesh is intersecting with the scene. So let me collapse this. For the parameters, we have a material that we can choose and play with. So here's the shader. For example, I can change this. And it updates. And this shader is a RGAP shader, not a visual effect shader, in unlit. Alright, so we have a material, then we have a mesh that we can also choose. And we have an anchor that we use to place the mesh in world space. So let's take a look at the C#. I think it's this one. Yeah. So we have the 3 parameters we just saw. We don't do anything in setup and cleanup because we don't need any buffer or whatsoever. And everything is in execute. So first thing, as I said earlier, when you want to draw something, you always have to start by saying, where do you want to draw your stuff? So this is what this line is doing. We want to draw our mesh on the camera color buffer. And we don't care about the depth right now. We do that in the next example. Then just ignore that and jump directly to that. We want to draw a mesh. So we provide the mesh. Then we provide the anchor matrix that will place the mesh in the world space. And we provide the material used to render the mesh. Submesh is useful when you have multiple meshes inside of a mesh, but here we don't have, so we just provide 0. And then the path. So the path is actually, you can think of the path as a sub-shader. Actually, when you make shader inside of Unity, there's multiple shaders inside of the shader because you need a part to render the shadows, render the depth, render the color. If you are using, for example, deferred rendering, you'll have multiple passes as well. And here we just want to render the colors. So we use a path called forward or forward only depending on how the shader was built. So to get the path, what we need is a path number, and to get it we just call find path, and it will give us -1 if this doesn't exist. In such case, we want to look for forward only. And actually you can take a look at the passes in the shader. So this is the material used, and if you select the shader and you go into view generated shader, you should see somewhere the path forward only. Yeah, so right here you have a path named forward only with the program itself. And as you can see, it's pretty big because there is multiple passes inside of the shader, even though it's a only shader. Okay, so next one does the same thing, but we implement depth testing as well, so that it interacts with the scene. So this is this script, I think. Yeah, it's basically the same. We only added few things inside of the execute method. So first we set the render target, but this time we want to set the test buffer as well, because we are going to do something. At the end we do the same thing, we draw the colors, and now we do a new thing. We use the depth forward only path of the shader to render the depth values into the buffer. And this is the only thing required to get the depth to work properly. Okay, so next one is how to draw a mesh in full screen. So drawing a mesh in full screen will be very useful if you want to do a full screen effect, basically, like a bloom, blurring, and stuff like that. And we will actually use that just after for the water. So to draw a mesh in full screen, it's basically the same as this one, but you just put the mesh in front of the camera. So if we take a look at the settings, we just have the material and the mesh, and basically it's always the same material. I can play with it. Okay, so for the custom path, I don't remember which one it is. Draw a mesh full screen custom path, it's this one. Okay, so the rendering of the mesh is the same as what we had before. The only thing that changed is that when we call draw mesh, we don't provide an anchor matrix, we create the matrix ourselves. So the matrix we create is a translate, rotation, scale matrix that tells to put the mesh just in front of the camera. So we provide first the position, then the rotation, and the scale. For the position, we just do position plus forward direction plus a distance so that the mesh is just inside the camera frustum. Maybe I should explain what's the camera frustum. So if you select the camera, you'll see some white lines. This is what we call the camera frustum. Everything that is inside the white lines will be rendered, everything that is outside won't be rendered. And you can play with the parameters to change the start and the end of this area. So what you see here is the frustum. And actually if I open the game and move the end to a higher value, increase the near value, as you can see, we'll start to see some clipping because the objects are not in the frustum anymore. So what do we want to do in our custom path is put the mesh just after the near clipping plane so that it's inside the frustum. Alright, so this is what this line is doing. Then we specify a rotation because we want to put the mesh always in front of the camera. If I enable the effect, no matter where I look, the mesh is always showing on top of the camera. So I just need to specify the camera rotation to do so. And then we specify a scale big enough so that it covers the the whole screen area. But if I put a small scale, you will see that it's too small. You will see how it's made. Yeah, it's just a quad in front of the mesh, of the camera. So that's it for the full screen effect. Okay, so next one is the same thing. It's just another way of doing it. And I'm putting that here for educational purpose because we won't use it for the water. So let's take a look at it. It's this script. So as you can see, the script is simpler. Before we had this, and now we have this. Unity under the hood will do something very similar to what we did just before. But I won't be using this technique because you can't use a shader that was made with the shader graph. You have to write the shader by yourself, like this one. So it's okay, but in this tutorial we'll stick to the shader graph. So that's why I'm not using this technique, but this one instead. Alright, then we have a full screen effect that actually uses camera data. So it's the same as this, except that the material will use the camera data. So let's take a look at the material. So before, in the shader, we had the screen position plugged into the color, but now we use the camera color that looks like this. We compute the invert of that color and we animate it. So we use the sinus of the time remap to 0, 1. It looks like this. And after the lerp, it looks like this. And that's it. So, but in Unity, we don't have yet a node to sample the camera color and the depth color. Not the depth color, just the depth. There's no such thing as depth color. So you have to use a custom function node and configure it. So in the GitHub, you will find a file called sample custom path buffers, and it's just a bunch of functions to sample the custom color, custom depth, camera color, and camera depth. You just drag and drop the file here. Here you choose the function you want to call. So there is multiple ones, and you just copy the beginning of the function. But here I want the color, not the depth. And you configure the input and output like in the function. So here is the input and here is the output. And it should sample the camera color. Alright. Next one is actually two custom passes. So the first one is what we saw at the beginning. We render the particles, but we render them in the custom buffer. And then we do a full screen effect that samples the custom buffer. So it's the same as this, what we just saw, but instead of playing with the camera color, we play with the custom color. If we take a look at the shader, this is the shader, and the only difference with before is that we don't sample the camera color, but we sample the custom color here. And we can maybe take a look at the rendering at the frame debugger. Here I put really bad values inside of the clipping planes. Yeah, let's play. And let's take a look at the frame debugger. Okay, so what we have here is somewhere fills the custom buffer. So yeah, let's take a look at the custom passes first. So we have two custom passes. One is called fill custom buffer and the other sample custom buffer. So fill custom buffer is here. It basically renders the particles normals into the custom path color buffer. And then we have the sample custom buffer path that just call this mesh, this shader, sorry, to draw a mesh in full screen. And actually, I forgot to mention, but there is a repository called ArchJP custom passes that is full of ArchJP examples, and this is where I learn how to use custom passes. So you have stuff like blurring, outline, ghosting effect, many things, and they even have the water effect, and this is where I learned it. And now we can jump into the next step. So with all this, we have everything required to do the water. So the next one is just the same as we saw before, except that we don't do any invert effect on the particles. So we render the particles onto a custom buffer, and we display the particles on top of the camera buffer using a full screen mesh. And the shader is this one. So it's the same as we had before, but we don't invert the colors at all. And also we use the alpha of the buffer to put them on top of the camera color, because if you don't use the alpha, you will get something like this, which is not an overlay, and we want to do an overlay. And to get the alpha inside of your shader, you will have to enable this in the surface option under surface type right here. Choose transparent. Alright, so now we can do some water. Here we have the water without the blurring. So this is the same as previous step, but only the material is different. If we take a look at the custom passes, we have the rendering into the custom buffer and the rendering of the mesh in full screen, but now the material is different. So let's take a look at this one. Okay, so this shader is a lit shader. We were working with unlit so far, but now we are using lit shader. It's a transparent shader with alpha clipping and refraction enabled. And actually, when you change settings over here, you should be careful that you should know that you also have to change them on the material right here. So it's actually more important to change them on the material. So I have the same here: transparent, alpha clipping, and refraction. And as soon as you do that, when you enable refraction and alpha clipping, you will have a bunch of boxes, a bunch of new settings showing up. And I just created properties in the blackboard for them, for most of them. So for the clipping threshold, metallic, smoothness, refraction color, and the thickness, and also the base color. For the alpha, I'm doing the same as before. So I'm using the custom buffer alpha. I just multiply it with a custom value so that I can play with the alpha here. And that's it. And now the new thing is that we actually use a normals value. So remember that at the beginning we saw the particles shader, we render the world normals. So now we use that. In the RGB we have the world normals. We just normalize it to make sure it's a correct normal data. We put it into tangent space, and we plug that into the fragment shader. If you don't plug the normal, you won't get the good refraction. And now we can play with that. Alright, so next step is blurring. Yeah, the rendering properties of this scene is quite bad compared to the first one, but it's okay. So now we have the same as before, but with blurring. If we take a look at the custom path, blur water normals, we have a combination of everything we saw so far. So we have some blurring. We blur the custom buffer. So the custom buffer is a buffer that contains the particles normals and we blur that. And then we render something in full screen, a mesh in full screen to display to show the water. And all this code is the same as the examples we saw before. There's nothing different or unique in this one. And that's it. So yeah, right now the rendering is not good. The rendering properties is not looking good enough, but that's okay. So one thing is missing though. If you put objects in your scene, like here I have a small scene, the depth is not okay at all. Like here the water should be behind the spheres and the cube, but the water is always on top of everything, so it's not good. We'll fix that in the next step, and we'll do some depth blending. So the custom path is the same, only the shader is different. If we take a look, it's pretty much the same, except that here we have two new things to compute the depth fading. So what we do is we sample the custom buffer depth. So remember here we sample the custom color, but we can also get the depth value. And we compare this value with the actual depth of the scene. And basically, if the water particles is behind an object, I want to put a value of 0 in the alpha, otherwise of 1. This is what this node is doing. It's pretty much like a if statement. Yeah. And yeah, that's it. Maybe I can show you how we can make this with a if statement. Maybe it's more easier to understand. So you'll compare the depth values. And choose the alpha values depending on that. So this is the particle's depth, this is the scene depth, and we want to say if the particle's depth is lower than the scene depth, we will get a true value, so a value of 1. And the depth value is actually smaller. This means that the particle is closer than the object behind. So here I save it and we get the same results. Alright, yeah, we have the same results. My explanation of the depth value wasn't so clear, so I just draw something on the screen. Okay, so here you should see some drawings happening. So the blue one is the forward direction, and here let's take this point. It's far away compared to this point. So this point will have a value of maybe 5 because it's 5 meters away from the camera, but this point will get a value of 20 because it's 20 meters away from the camera. What we do here is say, okay, if the test value is less, meaning it's closer to the camera, then we want alpha value of 1, otherwise 0. And that's it. So this one is this is the short for these two nodes.
That's it for me, guys. Thanks for watching. See you next time.